Cool. So, hello again, everyone. We have gathered here to talk about basics of, extremely basics of container orchestration. Container orchestration using Kubernetes, right? Please let me know if you also understand that this was the topic that we were supposed to cover today. Right? So we are going to talk about Kubernetes. We are going to talk about what is container orchestration. We're going to talk about what is Kubernetes as a solution for container orchestration. And then we will set up Kubernetes and deploy an application. Right? At the end of this session, I would like you to have an idea about what Kubernetes is, what problems it solves, not exactly in detail about how you can use it and various in-depth concepts of Kubernetes. We don't have enough time for that. But this should give you an idea about how to begin with Kubernetes. Give you a kind of a foundation on Kubernetes, right? So one thing that I expect you guys to already know is containers or Docker. Okay, let's quickly talk about Docker or container. What is a container? So generally, traditionally, if you develop a software, right, or a web software, what you do is you write code, right? You have your code, and from the code, you generate your binaries, right? And from the binaries, then you package it into some deployable artifact, and then you deliver it to the customer, right? Or you deploy it yourself. For example, if you are writing your software in, let's say, Java, you can write the code in Java, generate your, generate your classes, right? Class is, or let's say class file. It's nothing but the binary of the code. And then you generate a var out of it, right? Which is a deployable artifact, distributable artifact. And then you can deliver it to your customer. They can deploy it on their infrastructure, or you can deploy on your infrastructure, whatever you want to do with it, right? This is the final product. Now, if you want to deploy it somewhere, you need an environment, deployment environment. What is a deployment environment? It is nothing but a server which has required software, required settings or configs required to run this application which you are delivering, right? So maybe if it is a Java-based code, you may want to have a server which has, for example, Tomcat installed, right? And some JRE installed. And then you can run your war file, right? Compatible JRE and compatible Tomcat. And then you can run the software application that you have developed and compiled, and then end users can use it, right? Now, this is a traditional way of development. What happens if you containerize is that you don't deliver or deploy the war file directly, right? What you do is you take your deployable artifact and then you add your environment, which is required to run this artifact. For example, JRE, for example, Tomcat, right? And some configuration, whatever. You add this and then finally create a deployable image, also known as Docker image or container image. And this image is then distributed to the end customers. So your deployment engineers or your customers will want to use this image. So they take it and then they run it on their environment, right? This you should already know. This is a prerequisite of this session. If you don't know it, you can learn it later. But now you understand why do we need Docker and containers. Now, when somebody gets a container, let's say a customer gets a container, they will run it on their infrastructure. So they'll set up a server and they will install Docker on it or any container runtime like containerd or podman or whatever. They will install the basic runtime on it and then they will download this image on their system and then execute it and they get a container. Right? When they execute it, they get a process which is nothing but the container. Right? And this process runs the web application which can be accessed by the end user. Right? Now this is a single server running this single container. I should write container here. Running a single container. And that is a single point of failure. The single point of failure is what if this server goes down? Or what if this container goes down? You can't access this application then. So it's not a production ready deployment environment. Also, what if, there are, instead of one user, there are like a million end users who want to access this application. This single server may not be able to take the load of so many customers. So you want to scale your application. How will you scale an application? You will add more servers. You can add more containers, but the number of resources remain same. So you can add more containers, but then how will all this work together? Right? Now to solve all these reliability, availability, scalability issues, we have something called as container orchestration as a solution. What that does is, instead of running containers on one server, we deploy a set of servers, right? For example, let's say server 1 and server 2 and server 3, right? Server 1, server 2, server 3. And in all of them, you will install the container runtime, maybe Docker, maybe something else, container runtime, container runtime, right? So in all of them, you will install this so that they can run containers. And then you enable them to talk to each other, right? So through this, the internal network, they can talk to each other. LAN or WAN, whatever. They can talk to each other, right? Now, on the servers, you have the operating system. And you have the operating system, of course, running on all these servers. And on top of operating system, you install this container runtime. Generally, it is Linux-based OS. So you have an operating system and then you run a container runtime. Now, you install one more tool on all of these servers, which is a container container orchestration tool, right? Like Kubernetes. And what that tool does is it allows these servers to talk to each other and let each of the servers know about the states of the other servers. For example, how many containers are running on server 2 should be known to server 1 and server 3. How many containers are running on server 3 should be known to the other servers, right? So they all know about what containers are running on which server, right? And what that does is it allows you to treat this entire cluster as one single unit and you can deploy your applications there, right? Now, if this cluster is treated as one unit, and an DevOps engineer or a developer comes and says, hey, deploy my Nginx application, right? It doesn't talk to any one server and says, deploy this Nginx application. It says, well, I want to run this Nginx application. This cluster is going to figure out where this is going to run, right? Now, to make all these decisions, one of the servers assumes the role of a leader or manager, right? Or control plane, right? Other servers just assume the role of worker. So now a developer gives an instruction to the leader that I want to run an Nginx based application. And the leader takes this request and then tries to find out, all right, what are the containers running on all the servers and which server is less loaded. Let me go ahead and run the container here, right? So it finds a place for this container to run. The advantage is now, if this container crashes, the leader immediately comes to know that this container has stopped running and it tries to find another place for this container. Maybe this server or this server itself, right? This is one advantage. Another advantage is the customer can say, hey, I'm running one instance of this application, but I want to maybe scale it up to 5 instances. I want to run 5 instances of my application. Then the cluster is going to run more containers, right, across the cluster, distribute this load across the cluster, and any end user can then access the load balancer, which is in front of these containers, so that they can talk and get access to this application. They can change the scale. Later, they can say, hey, I want to run 10 containers. So add more containers here, right? They also become part of the load balancer backend. So the user can access them as based on the front end load balancer, right? This also gives them high amount of resiliency. If this entire server 2 crashes, then we still have these server 1 and server 2 running. Even though server 3 is gone, we still have 6 more containers running. We lost 4 containers. So the application doesn't go down. The load balancer just misses these applications running here, but there are still 6 more backends. And then cluster will immediately, the leader will immediately understand that, hey, this server is down. Let me find a new home for the 4 containers that are not running, right? So slowly it's going to bring the application back up to the required scale. Okay. So this is the basis of container orchestration, how you can run containers on a cluster rather than running on a single server, on a cluster of servers, so that you can achieve high scalability, availability, and reliability of your system. Okay. And if you feel that the containers are like choking the system, there is no more resource available on the servers, you can always add more servers, more worker nodes. Server 4, right, which can talk to the cluster. Server 5, you can have n number of worker nodes. Okay. Now, this is the basic understanding. Now, let me show you how you can set up a cluster, right? It might be a lot to digest everything, right? But it's pretty straightforward. So this is my AWS account. Let me create 3 servers. Guys, hold on to your questions. I'm going to open the floor at the end of this session, maybe at 2:45, and then you can ask me any questions, right? These questions in the chat, I can see them, but I cannot answer them as of now. Most of them will be answered automatically as the session goes on, right? So let's say I want to create 3 instances. Now, this is not a AWS class, so I'm not going to show you what is happening here. I'm just going to continue and create 3 machines. This is it. And let's create 3 instances. So we have 3 machines right now, and all of them are pending or starting. One of them is running already. 2 are running now. I don't know why this is pending. Okay, I'll wait for it to come up. Right, that's okay. So let me connect to the leader ones. Right, I'm going to connect to the leader machine. Right, so this is my leader, and I would like to install. Right, it is running now. Okay, so this is my leader. Let's connect to all the machines. Give me a second, please. This is the W1. And right, so this is my worker 2, and this is worker 1, and this is the leader. Right, I have all my machines connected. Right. Now, what we are going to do is we are going to convert these 3 machines into a single cluster, right? Or a cluster which can talk to each other. And we are going to use Kubernetes for that. Okay. Now Kubernetes is a tool which was developed by Google, and they used it internally for a long time, and they made it public later, and it is now available as part of open source. What happens is when we want to set up a Kubernetes cluster, we do this, right? So we get some servers, let's say 3 servers that I have, right? Leader, worker one, and worker two. And on this machine, we are going to install all the control plane components. And there are many components, like there is an API server, which is nothing but a web server which listens to the requests to deploy um, uh, contents or to deploy applications. There are other components as well. As and when we come to talk about those, I will talk about those. Then there is something called as kubelet, and the kubelet is installed on all the machines. And this kubelet is like an agent which talks to the API server. So kubelet gives information to the API server, and it tells API server about what is happening on the servers, on their own servers. So this kubelet is going to tell the API server that, hey, 5 containers are running. One container is taking this much space, second container is using this much RAM, third container is using this much memory. Everything that is happening on this particular worker node will be sent to this API server by this kubelet. And kubelet can seek any information from the API server also. If kubelet wants to know what containers are running on W1, it can request the API server and get the details. Similarly, this kubelet can say, "Oh, okay, how many containers are running on the leader?" It can also get the request. Okay, so kubelet is like an agent which runs on all the machines. So as part of this Kubernetes deployment, we are going to install all these components on the leader as step one. And then step two is install kubelet on all the machines. Okay, right. So first thing is to install all these components, we need some tools on all the systems. So on all the machines, I'm going to set up everything required. Okay, so first thing is that we download the key for the repository that we are going to add to this Ubuntu yum, sorry, Ubuntu apt. We want to download certain tools and they are available in this repository, apt.kubernetes.io slash whatever is there, Kubernetes serial mail, right? So I'm going to now, after adding this, I'm going to do apt update. And you can see it can now talk to this Kubernetes resource APIs. I'm not sure why it is not working. Maybe this is not a correct one. Let's see. Let's see if the APIs have changed. This one is not very helpful. Right. So let's run these commands. These are the commands that we should run. Okay, that is done. Then we get this. All right. And then we get this. Okay. And then we do this. Let's hope this one works. Right. So they have recently changed the URL to something like this. So now this is going to work. And you see here, as part of this command, we added this repository, right? And then we say apt install kubelet, kubeadm, and kubectl. So we want to have these three tools running on all the machines. Okay. Also, we want Docker to be running on all the machines. So let's find out the latest version of Docker, or I would say containerd. Give me a second. They have changed a bit. So let's install containerd. Okay, so it comes as part of Docker, right? So let's do this. Now we want to install Docker and all its components. So from the Docker website, this is the way to go. So I copy this and then I copy this. And this is going to install everything required. So in the first step, we downloaded all the tools required to set up our Kubernetes cluster. And in the second step, we have downloaded everything required to run the containers, which means the container runtime. So the first step was to get these tools. And the second step was to get this container runtime running, CRT. Right, that's what we have done. I can share the notes later. And now what I'm going to do is on this machine, I'm going to say kubeadm init, and the node name is control plane. So I'm going to initialize the cluster. Okay. And here it says, right, so it says we don't have enough RAM. And for that, what I'm going to do is I'm going to say ignore pre-flight errors. Right. So I said ignore these errors. Okay. It says this is not. Hmm. It says container D is not running. Okay. Just give me a second. Mhm. Let's debug this quickly. All right. Yes. So sometimes we have to fix this thing. Right. Now I remember why this happened. I've seen this error before. Right. Now it works. So there was by default containerd comes with this configuration file. We need to remove that and then restart containerd. So containerd is nothing but underlying container runtime environment. Okay. And now you can see it is configuring the system. It is doing some stuff and we are not bothered about what it is doing as of now. We just watch it. Connection refused. Right. We have very less memory on this. Okay, just give me a second. Let's fix that. Although I was able to run the or start the cluster, the thing is it requires a little bit more memory, right? So what I'm going to do is the leader, I'm going to change the instance type of the leader so that I get some more resources or some more memory and CPU on this. Okay, now it is stopped. I am going to say change instance type. I'll change it to T3 medium. Okay, and then I say start. It is running now. Let's connect to the system again. Okay, IP address would have changed. Right, we are back in the machine. And now we see we have around 4 GB of RAM, right? It should be good. I'm going to delete the cluster that I created. Right, and now I'm going to do an init again. Done. So my cluster is up. I don't have any errors. Now, all I need to do is run these commands on my local system and done. All right. Now I have to do same things or almost same things here. So I need to install kubeadm, kubectl. At least I need to install the kubelet tool on all these worker nodes. So I'm going to quickly make that on both the worker nodes. So I run this command, then I run this one. And finally this one. Right. So now all these machines will have the same tools. And I also want containerd, so I will also install Docker and its components on all the machines. And we will fix this error as well on both the machines. Done, right? Closed. Now, this is my Kubernetes cluster. This is my leader, and I am logged into my leader, and my cluster is up. Okay. Now, I want this worker node to join this leader, and this worker node also to join this leader. Right. So now what I'm going to do is, when I started the cluster, it would give me this output to join. This is a command which I can run on any machine to join. So I am going to become root on this worker node and run this join command. Similarly, I will become root and run this join command. So after this join command is run on the worker nodes, I will get this output that this node has joined the cluster. And here also this node has joined the cluster. Fine. Now my cluster is set up. All my components are installed here. The kubelets are installed here, and these nodes have joined the cluster as well. Right. So let me show you how the cluster works. Now there is a tool called kubectl, and this kubectl tool can interact with the cluster. So what this kubectl does is, anybody who wants to interact with this cluster, they use this tool, kubectl. And kubectl, when you run the commands in kubectl, it talks to the API server and gives the command and gets the output and gives me back the output. So let's see. If I run the command kubectl get nodes, I see that there are these nodes, and these nodes are created, but the nodes are not ready for some reason. Yeah, the nodes are not ready as of now, but the nodes are created. Okay. So kubectl command can talk to my cluster and get me some information. Kubectl get nodes gives me information about what are the nodes running on my system. So I have one control plane node, which is the leader, which is this machine itself, and the other nodes, which are the other machines. It is not ready because a couple of components are missing, right? And the component that are missing are, wait, let me, yes, I'm looking for it in my notes. So let me just find out here. Right. So what I'm going to do is, let's see if this works. I have to install the network component in the cluster as well. So the cluster nodes are not yet aware of each other because they don't have internal networking setup, right? So I need to install networking, and for that, Kubernetes does not come with the networking component built in. right? So I need to install it. And let's see, this will work. Right, so this is done. Let's see if we get a better results with this. It looks like we lost the connectivity. Ah, come on. For some reason, the node connectivity is gone. This should not have happened. The 6443 port is running. Our components are running. Give me a moment. Right, so it is like this. It should have worked. All right, love. Okay, maybe it took some time. Okay, now I can see something, but because Cilium is, I think, uninstalled as of now. Let's try some other network. Let's try Calico. See, the cluster has stopped responding again for some reason. So what I would have done after this is, we need, when we run the containers inside our pods, the containers should get IP address, and each of them should get an IP address, and they will all be able to talk to each other. All these containers can talk to each other. And that requires an internal networking to be set up, right? And that is not provided by Kubernetes. Kubernetes defines the standards on which the networking shall be created, but it doesn't provide any networking implementation. So we need to find third-party networking implementation. For example, we looked at Cilium, which for some reason didn't work. Maybe there is an incompatibility. We are also looking at Calico right now, which also, for some reason, the cluster has stopped responding. It is still not responding. So um, any of these tools, there is Calico, there is Cilium, there is, I think Nginx also sets up something. And then it allows to set up this networking internally, and then the cluster becomes ready, right? So unfortunately, we are on the dot. This cluster did not come up. I think Kubernetes has changed something very recently. Now, if this was up, I would have simply created a Kubernetes deployment by using the command kubectl create deployment, which will create an application and the containers for that application. And I could have shown you how the containers are created and distributed across the cluster. Okay. So sorry about this, that the cluster could not come up in time, but maybe we can have another session and get things to working if possible, right? I can take some questions. There were some questions already asked, so I will check them, or you can ask me the questions, right? So there were some questions like, can the leader run containers? Yes, the leader can also run containers. It will be running containers, at least the system level containers by default. Right? Docker is free, but if you are using it in professional environment, then you have to pay for it. You have to get a license for that. What will happen if leader fails? All right, if leader fails, then you can see all other worker nodes, stay like orphans. That's why when we set up a Kubernetes cluster, we have multiple leaders or multi-master. In that way, we can have kind of a high availability of the cluster. So we don't have one leader, we have multiple leaders in production deployments. How are the pods related to containers? So pods are wrappers around containers. So when I was saying that the containers will be run by Kubernetes, so these would actually be pods. And inside the pods, there will be containers running. A pod is nothing but a wrapper around container. Think of pod as a very, very small virtual machine and a container like a small process inside it. Okay. All right. So thank you for the questions. Maybe I will ask to Skill Upright team and let's see if we can have one more solution, one more session. Okay. Question from Ravi. How many maximum leaders we can assign? You can have all of the workers as leaders, but then all of the workers will be overloaded. So that's why you have minimal number of leaders, but enough to provide you resiliency. Ravi, yes, you are right. All right, guys. Thank you. I see that we everyone have next discussions to go, next appointments to go. I'm really sorry that we couldn't set up this cluster completely. Doing it after a long time, so a lot of changes from Kubernetes side. But thank you for your attention, thank you for your patience, and I'm going to see you next time. Thank you and bye bye.